So what we've got then is this is one of the hardest kind of partial fraction questions you'll get. The reason it's hard is because it's top heavy. Because the highest power on the top is bigger or equal to the highest power on the bottom. So it's top heavy. And if you think back to just like standard fractions, if you had something like 9 divided by 4, which is top heavy, what you would do is you would make it into a whole number and a fraction. So what would the whole number be? 2. So 4 goes into 9 2 times, with 1 left over, 2 1/4. So the first thing we need to do is a similar thing with this fraction. We need to divide out. And this goes back to what we did at C2. So we set it up like this. We've got x cubed plus 2x squared plus x. We're going to see how many times it divides into 3x to the power of 4, 7x cubed minus 5x plus 1.
Oh, so it's that long division.
That long division thing. I've set it up incorrectly, really.
Done it with 3 numbers before.
We haven't. Don't worry, you can do it.
Okay.
So I've missed something out there which is worth putting in, which is the
squared.
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 Let's sneak the 0x squared in there. And it looks horrible because of the fact that we've got this thing here which has got 3 bits in it. It's the same process. So how many times does x cubed go into 3x to the power of 4?
3x.
3x times. So we put that in the x's column. Then we do 3x times by x cubed, 3x4. 3x times by 2x squared, which is
6x cubed.
3x times by x, which is
3x squared.
and then we subtract to find the remainder.
1x.
So we get that's 0, 7x cubed, take away 6x cubed is x cubed. 0x squared, take away 3x squared.
Minus 3x squared.
And then we bring down the minus 5x. And again, how many times is x cubed plus
So you
2x?
can ignore the plus 1.
Exactly. Well, you can bring the plus 1 down as well if you want in this case, which is fine. And then how many times does this go into this? Once. So I've got my plus 1 there. I've got x cubed plus 2x squared plus x. And again, subtract to get my remainder. So 0 minus 3x squared.
5x squared.
Yeah, minus 5x squared.
Minus 6x squared.
No, just minus 6x
6, I mean.
and 1. Alright? So we can rewrite this thing here as follows.
Oh, is that the remainder?
So that is the remainder. Exactly right. So what we have is, again, 3 lines because it's equal at all times.
Wait, why is...
So this is effectively the whole number.
Okay.
So this goes into this 3x plus 1 times.
And then
But
minus
why
5x
can't you
squared
divide the
minus
bottom
6x
again?
Because that's x cubed there, isn't it? And the biggest power I've got here is x squared.
Oh, okay.
So 3x plus 1 is my whole thing. My remainder is this thing here. So minus 5x squared minus 6x plus 1 over x cubed plus 2x squared plus x.
So do you need to put the whole thing over x cubed? Can you use just that?
You need, so because it's a bit like, remember we did 9 over 4 was 2 1/4. So 4 goes in 9 2 times, the remainder of 1 needs to go over that 4 there.
Yeah. And do you factorise the top and the bottom?
You can't factorise the top,
Well, you factorise the bottom.
but you can
divide by
factorise the
x,
bottom.
Then it'd be x plus 1 squared.
Perfect. So factorising the bottom gives us x times by x plus 1 squared. I've basically done that on a board, which is great. But in case you can't see why this is the same as this, firstly, this has got a factor of x, which is x squared plus 2x plus 1. And then the factorisation of this is x plus 1 squared. And once we got to this point, we can now do the partial fractions like we did previously. So if I just look at this bit here, I've got
Just ignore the 3x.
we'll just leave that in at the end. So this bit's the only bit we can divide up into partial fractions. So we've got minus 5x squared minus 6x plus 1 over x plus 1 squared is equal to, what are my 3 partial fractions?
Minus
X
squared minus 6x and 1.
Nope.
X plus 1 squared and x plus 1.
Those are the denominators. X plus 1 and x plus 1
And there's
squared.
A, B, and C at the top.
And then a, b and c at the
And
top.
then you have to substitute and do that.
And then you times.
Then you
bottom,
times.
And then you cancel them out, and then you get
Precisely. Times, cancel out.
minus 5x squared equals a bracket something plus b bracket something plus c bracket something.
Yep. You get that like that. So my sensible values for x this time?
Let's have
I'm gonna go-
-1.
X is equal to -1 is sensible. So if I put -1 in here, I get -5 times -1 squared. -6 times by -1 plus 1 is equal to, that goes, and I end up with -c there. So that is -5 plus 6 is 1 plus 1 is 2. So -c is 2, so c is equal to -2. Another sensible value of x to choose?
0.
0. X is equal to 0 means I get 1 is equal to 1 squared, which is 1 obviously, so I get a, that disappears, so I've got a is equal to 1. Sensible value of x to finish it off? 1, yeah. None of this is going to disappear because we've used all those sensible values up, but if I choose x equals 1 and then use the fact that a is 1 and c is equal to -2, we should be able to find out what b is. So swapping 1 in there, -5 times by 1 squared, -6 times 1 plus 1 is equal to, 1 and 1 is 2, 4a, yeah, 2 squared is 4, so 2a plus,
2b.
or not 2b, that is the rather poor maths joke, and then plus c, and then I've got a is 1, c is -2, and I can swap that in there, so -5, -6 is -11, plus 1 is -10, 4 times a is 4, plus 2b, c is -2, so we end up with 2b is equal to -12, so b is equal to -6. So coming back, we'd finish this whole thing off by saying, I've run out of space.
Just roll out the A, B, and C.
I'm going to go, I'm going to go, what's my
Just
B?
do that. Just do it in the
I don't really want it, I better run out of
Do
water.
it in the
So just
bottom.
roll out the
Do it in
A, B,
corners.
and C on the original, like,
Can't you just
set out
turn the
thing.
camera?
That's too technical to turn the camera.
Just roll
Right,
out the A, B, and C.
let's get rid of that. So we get that, A, B and C become A is 1, B was equal to -6, C was equal to -2, so this whole thing is 3x plus 1 plus 1 over x, -6 over x plus 1, -2 over x plus 1 squared.
You circle it.
Oh my god.
Well, that's hard. That's as hard as it gets, but it's got all the techniques in there that we need. So, this is as hard as it gets with the partial fractions. This is a top, wow, it's not a top heavy fraction. Right, let's start again.